filled in the stuff from that I think that y'all were able to get. When I walked around, y'all were doing pretty good. Are we okay with those? All right. And as far as what the graph look like, then we have some words. You want to guess? Positive. I like that. Okay. Anything else? Ooh, and linear. I like that. What does linear mean? What does linear mean? Make a straight line. Okay. Make a straight line. Okay. Anything else? Steep. It was pretty steep. Okay. That's fine. Okay, we're good. For part F, how did y'all get the y-intercept of that graph?
I went, instead of adding things because it's going to the right, I'm subtracting, I'm going to the left.
Okay, so
here,
good. If you have a table, how do you know in a table if you have a y-intercept? Not in a table. Like if I'm just looking at a table, how do you know where to find the y-intercept if you have a table? When x equals 0. So what you were saying, we know that going forward it's going up by 1. So does that 0 fit the pattern? Just reverse it. So since this is adding 3, reverse it. What would it be if you reverse it and go backwards? You would subtract 3, which is 4. Isn't that the same? Okay, so go backwards in the table. Did anyone do what we were doing the past few days? Did anyone use that equation? So you use y equals mx plus b, and you put in, like, if the ordered pair was 1, 7, you did this, and solved it. Okay, so let me go. What we're doing today, we're going to be doing this one a lot, where we're changing, or we're going backwards in the table. You could still do what we were doing the past few days, but we have a lot of table work today, and if the table is easy to go backwards or easy to find the 0 for x, that's usually a little bit faster than making an equation. For the last part that y'all were doing, you were writing it in slope-intercept, or you were writing an equation for that sequence. It's slope-intercept form. Did anyone figure that out yet?
Y equals 3. X plus 4.
Wonderful. Y equals 3x plus 4. That is perfect. It does say to write it using function notation, so we're going to be doing a lot of function notation. So instead of y, it's this. So t of n equals, and 3 instead of x, it's an n plus 4. You could get those values also from looking at your table. Instead of x and y, they use those two parts right here. All right. What we're looking at today is called arithmetic sequences. This was an example. So this right here, 7, 10, 13, 16. That was an example of an arithmetic sequence. Arithmetic sequence sounds complicated. It's just a list of numbers that you add or subtract the same number each time. That's it. So it's just a list of numbers where you add or subtract whatever that number is. Move through it. Because the sequence is just patterns. So an arithmetic sequence just means a pattern of numbers where you're adding or subtracting the exact same number each time. Since we're going to be adding or subtracting the same number each time, that means our arithmetic sequences are going to have a constant rate of change. When something has a constant rate of change, what does that mean? It is linear. It's going to form these nice, pretty straight lines. Hence our graph. All right. So now let's take it into that next part. Part 2. Here's our sequence, the one we were just working with. 7, 10, 13, 16. Is it possible for 200 to be a number in your sequence? Is that possible?
Yeah.
How do we know? Wait, divide 200 by 3. 16 is in our sequence. Is 16 divisible by 3?
No.
Okay. Then that doesn't work. Yeah, 13 isn't divisible by 3, but it's in our list.
Get the -1.
Oh, what do we have to do?
-1.
We have to subtract 4. Why would you have to subtract 4? Because it was your y-intercept? Okay, so, to figure out if it's in our sequence, what would we have to do 2 steps. What would those 2 steps be? Subtract 4, and then what? Divided by 3. So, those 2 steps, I'm going to show you something. I'm going to give you an equation. 200 equals 3n plus 4. If you solved that equation, what would your first step be? Is that what you guys told me the first step would have to be? What would my next step be of solving this equation? Divide by, isn't that what y'all just told me we have to do? Okay. So, what we're looking at, if it was asking, is it possible for 200 to be in your sequence? It's asking, is it possible for 200 to be a y value in your table? That's where I just made up that equation from. I plugged in 200 for y. Now, does this divide nicely? Is 196 divisible by 3? No. So, we're talking about sequences. Sequences are positions. So, think of these numbers, they're standing in line. 7 is the first thing in line, 10 is the next thing in line, 13, 16. If you're standing in line, are you going to be in the position of 196 over third position?
No.
If you're standing in line, or if you're in a race, do you finish 3rd and a half place? No. So what kind of numbers should we be looking for here? You need whole numbers. So if you're given this question, when you plug that number in for y, you should be looking for whole numbers. So our answer is no, it's not a whole number. That's what you're looking for. To be in a sequence, a position, like when it's where it's located in your list of numbers, has to be a whole number. So all we're doing, we're still writing equations, we're still doing all the same things we were doing before, but now it's just not seeing it as a table officially, but it is still a secret table. What I mean by that, here's a list of numbers, new numbers. 5, 8, 11, 14. What's that going by? Okay, so it's adding 3 each time. This, anytime you see a sequence, it's actually a table. It's just not fully made for you. How is a table? This is saying the first term is 5, the second term is 8, the third term is 11, the fourth term is 14, so we can turn it into a table. Like we just made a table. The goal is now write an equation in slope-intercept form. What 2 things do you have to have for slope-intercept form? Slope and y-intercept. So for the slope, change in y. How do you get from 5 to 8? Adding 3 as x goes up 1. So what would the slope be? 3 over 1, so 3. Good. And then the y-intercept. For the y-intercept, this is where we have to be a little bit careful. That's what we were doing just before. A y-intercept in a table. How do you find it? X is 0, so we need to go and do the opposite operation, which is going backwards, subtracting 3. So 5 minus 3 is 2. So our y-intercept would be 2. To make the full equation, y equals 3x plus 6. Do y'all feel like you did the second one? Okay, do number 2. If you want to do number 3, you're welcome to, but just do number 2. All right. We're going to skip C. We're going to go through. For the most part for today, we're going to be skipping a lot. Don't lose this paper. We're going to come back and do this, so don't lose it. But we're going to be skipping a lot. This next portion, we're going to get into vocabulary and notation. So hold on real quick. We've got vocabulary, we've got how you're going to see it. Because what we're doing are all these sequences, but because it's a sequence, it's a special type of linear situation, so of course math has to have all these special things to go with it. All right. First special thing, it has the name. The name is an arithmetic sequence. All that means is that we have a list of numbers where you are adding or subtracting the same number to move through that sequence. That number that we are adding and subtracting to move through the sequence is called a common difference. That's your number that you're adding or subtracting. So it has a nice fancy word to it. Common difference. We're going to see formulas and equations and just like it's going to be throughout. But the common difference, we use the letter D whenever we're talking about it. Okay, so then for this example, all of our sequences, we use function notation. We use function notation a lot. So here's the sequence. If we are going through, what's it doing each time? Adding 2. So your common difference is 2. Then the next part. If we're talking about this sequence, this is your first term, second term, third term, fourth term, fifth term. What you will be seeing is function notation. How it's showing you function notation. You'll see things like f of 1. F of 1 equals 6. What that means is that the first term is 6. Or if you see something like f of 5 equals 14, this is incorrect. The fifth term is 14. So that's how you're seeing the function notation. Now back when we did function notation, there's a type of function notation that we just haven't shown y'all yet because I don't want to overwhelm you with it. But now that you've had to practice, now it's done. The other way to write function notation, instead of the parentheses like this, is what's printed on your paper. It's these little subscripts. So like that tiny little subscript, A with the subscript of 1. This is still saying the first term is 6. The second term is 8. The third term is 10. Fourth term is 12. Fifth term is 14. So it's still just a form of function notation. But instead of parentheses, it has these little subscripts. Subscripts are those tiny little numbers below. Those subscripts are just used to like help label things. That's why we see them. We'll see that plenty. So we're going to go back and forth between the little subscripts and then like the parentheses that you're used to. We're going to go back and forth within notes, within like questions, on test quizzes. Like it'll always be either option. So you'll see both plenty of times. We're going to go down to this next part. We got a list. Here's our first problem. We got a list of numbers. Is it arithmetic? Okay. What's it adding by each time? So it's adding 2. What will the next 3 terms be? 13, 15, 17. Okay? What I want y'all to now do, I want y'all to answer the other 3 from that section and answer those graphing questions below. Okay. Y'all were good for this part. I want to check everyone so you're good. So we're going to go to the bottom, the graph part. You should have had, is the first one arithmetic?
No.
No. Should have no and then yes, yes.
Yes.
Okay. What are you looking for? Yeah. Is it linear? Is it a line or not? The other thing you could look for, The x values, when we're talking about these sequences, the x values are always going to be the same. Because it's always where something is in a sequence. So your x values are always going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. It's the y values that you pay attention to. Those are the numbers that you look for to see if it's a sequence or not. Going from 0 to 1 to 4 to 9. Is that adding by the same thing each time? No. But if we look at number 14, is that adding by the same thing each time? Yeah. What? Okay, so you're calling difference between 10. What about here? It's subtracting 3. Okay, so explanations of why something is or is not an arithmetic sequence when it's a graph. You could say that it's not linear. That's a good option. You could say it does not have a constant rate of change, because that implies linear as well. To say that it is, you could just say yes, it is linear. Or it has a constant rate of change. The common difference is -3, the common difference is 10, whatever. Things like that. Okay. Now we're going to get into more types of problems you'll see on like tests and quizzes, work, things like that. So if you go to the next page, before we get into it, because it's going to deal a lot with the equation parts. So let's talk about the equation. How can you write an equation in slope-intercept form? So what two things do you have to have to write something in slope-intercept form? Slope and y-intercept. Okay. When we are writing the slope, or getting the slope, what is that in your sequence? It's your common difference. It's whatever you're adding or subtracting by each time. So when we're writing something in slope-intercept form, the common difference is the slope. Okay, and then the y-intercept. How were we getting the y-intercept to write those equations earlier? Reverse, go backwards more. That's kind of makes both go. So reversing it, you go back one spot. So we're going to look at number 17. I'm going to change our directions. All we're going to do for number 17, write the equation for it. So there's our sequence. It is a hidden table. That table will be 1, 2, 3, 4. Okay. There's the table. To find the slope, it's our common difference. What's happening there? It's subtracting 5. So when we write our equation, it would be -5, and we typically use n instead of x for our sequence. If you use x, I'm not taking off. That's okay. Okay. What do we still need? The y-intercept. So to find the y-intercept, go backwards one in the table. We were subtracting 5, so do the opposite, which is adding 5. 43 plus 5. 48. So plus 48. How do you feel? Good? You already tried 2 on your own? Okay. I want you all to do number 19 and do number 21. Okay. 19 looks good. For 21, as you go forward, what's happening to it? Yeah. It's subtracting 2/4, which is equal to 1/2. So I'm going to write it the simplified version. So -1/2 n, and then plus 11/4. Keep it as fractions because the sequence had fractions. If the sequence had decimals, then we can write it as decimals. But generally, you want to keep it how they had it. Okay. We're gonna go to the next section. So there's 4 sections that we have today. Just one. Now we have 3 more to go. Next section. All I'm gonna have us do, is it arithmetic, yes or no? If it is yes, we're gonna write the common difference. I'm not gonna have us write the formula for this one. We just did that. Let's look at number 2. Is number 2 arithmetic? Okay. How so? Why? It is consistently subtracting 6. So, yes, the common difference is -6. Number 4, is number 4 arithmetic? Well, I'm below it. No. Does number 4 have a pattern? Okay, so things can have patterns, but that doesn't make it arithmetic. What's the pattern for number 4? That's good.
Just putting a number in there.
If adding an 8 to the end, that's exactly right? Multiplying it by 10 would make it like, yeah, ending in 0, right? I know, tricky. Makes your brain crazy. Okay, what about number 8?
Yeah. We only do.
No,
it's not.
Okay.
It's only adding and subtracting. That's multiple.
say it, Julia, say it louder.
We don't multiply, so it's not arithmetic.
Correct. This is multiplying by 2. Arithmetic is only at addition and subtraction. So that answer is no. Arithmetic is only addition and subtraction. There's a different type of sequence which involves multiplication. We're not there yet. Okay, flip to that. 2 sections down, 2 to go. Next part. The directions for this, we're going to follow through with those exact directions. We have our sequence. They're giving us the equation this time. It doesn't work, explicit formula. We'll talk about explicit formulas on Monday. We're finding the common difference and then using it to get the first 5 terms of the sequence. So, number 12. What is the common difference for number 12? Common difference is 5. What will the common difference always be with? N. It's always with your letter because it's always your slope. It's always the thing that is constantly adding or subtracting, which means it's a repeated thing, which is why it's the letter. Next part, find the first 5 terms. What would the first term of the sequence be? 8. Not 3. 8 would be correct. Why is it not 3? 3 is the y-intercept. What is x when you have a y-intercept? 0. You don't have a 0 position in a sequence. So, we only start, when you start a sequence, you have the first term in a sequence. So what you're doing is plugging in a 1 for your n value, which is where the 8 comes from. Because 5 times 1 plus 3 is 8. What would the next number in the sequence be? 13. We use our common difference. It's adding 5 each time. So 13, then what? 18, 23. All right. First 5 terms. We only have to do 5. So let's look at number 14. Do the same thing. What would the common difference be on number 14?
-6.
-6 is had the fine sign for. Make sure you're careful for details. What would the first term be for that? 28. 22. Okay. Why is it 22 instead of 28? 28 is the y-intercept. Your y-intercept isn't a position in a sequence. The y-intercept is the 0 term, which isn't a thing. You have the first term in a list, first number in a list. How you're doing it, you can do 28 minus 6 times 1. So 22 is your first number. Then subtract 6 to move through. What's the next number? 16, 10, 4, and then we're done. Okay. Do number 16. Okay. Are we okay with this? Last section. Last section, it's giving us some function notation practice. So we're going to look at number 20. Directions, we're given the first and we're given the common difference. Find, write an equation, we're writing in Slope-Intercept form, and then find the term for whatever it's saying. So we're looking at 20. Number 20, what does that thing that is underlined? A sub 1 equals negative 31. What does that mean? That means the first term is negative 31. So the first term in our list would be negative 31. What does this mean? That's your slope, that's your common difference. So to move forward, we would be adding 9.
Negative 22.
So negative 22. And but we're not asked to make a list. We're asked to write the equation and then find a sub 36. So if we're writing the equation, we have the slope. So that would give you 9n. What would the y-intercept be? Negative 40. Because remember, y-intercept, we have to go backwards, which means we would subtract 9. So minus 40. Okay, that's the equation part. The next part, find a sub 36. What is this asking you to do? Find the 36th term. So instead of, you're not making a table all the way to 36. No one has time to think about that. What are you doing instead? You take this, the equation we just made, put 36 in the n spot. N is representing the different places in your sequence. So 9 times 36 minus 40. And then you guys have to type it. Same process for 22. First term is negative 40. Our common difference is negative 100. So when we're writing this out, our first term is negative 40. Our common difference is subtracting 100. So this would be negative 140 for the next one. But if we're writing in slope-intercept form, what do we need to do? Go backwards to find the y-intercept by adding 100. So what's the y-intercept? 60. So what would the equation be?
Y equals negative 100 plus
N plus 60. Okay. There's your equation. And then it's saying to find the a sub 30 term. That means what is the 30th term? That means take your equation, plug in 30. What is that answer? Who calculated it? What is it?
Negative 2,904.
2,904. Calculator ahead. Okay. Y'all are doing number 24. When you have the answer, let me know. I'll come check it, give you a sticker.